Okay, next we will move on to intermediate part 1. This is also one of the model we covered during the workshop. So let's start. Create a new part and save it. Do know that in this question, the unit is in IPS, which is stands for inches, pounds, and second, which is the empirical units what the Americans are using right now. So at the bottom right corner over here, instead of MMGS, we switch it to IPS. So let's start. We can start the first sketch on the top plane. We will first extrude this rectangular base. Like what I've introduced previously, I personally would like to use this center rectangle so that this front plane and right plane can be used as the plane of symmetry or reference plane at later stage. So so this dimension is 3, this is 4. This is 3, this is 4. Okay, yeah, this works. But let me see. Okay. Seems that the orientation is slightly different. Okay, but it doesn't matter. In this orientation, it will be same as what indicated in this image. But if you want to be slightly more convenient, you can just switch the dimension, switch this to 3 and switch it to 4. So that the default isometric view will be exactly same as this. Yeah, but this is not a compulsory step. So next step, oh, okay. I think I forgot about one thing. Define the global variables. So there are two global variables, A and B. A is 3 and B is 1. So we set A as 3 and B as 1. And press OK. We know that we need to extrude it for a height of B. So we go to extrude and then go to blind, then equal sign global variable B. Okay, I accidentally click on the collapse feature tree. So global variable B. Next, we need to draw this slanted. We need to draw this slanted feature over here, and the whole feature is slanted by 48 degrees. 48 degrees. So in other words, all these sketches need to be completed on a plane that is 48 degrees. That is 48 degrees with respect to this top plane, and this plane is the axis of rotation is this axis over here, which is 2 mm away from the side. In other words, this is the center point. This is the center line of this rectangle. So first things first, we create a new sketch and we define this center line over here. We save the sketch. Then after that, go to reference geometry, plane. We want this plane to be to be at a certain angle with respect to the top plane, and also with respect to this axis. So here you can see that first reference, second reference, and third reference. So for the first reference, we can click on this plane, this top plane, and the second reference, we can click on this dotted line or this axis. So over here, under the relationship, you can see it automatically selects perpendicular, which creates a plane that's 90 degrees with respect to this top surface. We don't want it to be 90 degrees. Instead, we want it to be 48 degrees. So we change it to 48. And yeah, is it 48? Yeah, it's 48. Then press OK. We can see that this plane has been created. Then click on this plane, create a new sketch on this plane. We will create this door-shaped sketch. Actually, this is just half of a slot. So let's start. We need these two to be tangential. Okay. This line should be vertical. Yeah, we add the constraint. Then we know that the center point of the arc or the semicircle is 4.5 inches away from this front edge. So in other words, it's from this point to this edge is 4.5. And you can see this sketch is fully defined. Then after that, we can extrude it. Over here, we can see that it extrude towards this direction, and basically it extruded like this. And this point just nice merges with one of the corner vertices of the rectangle. So the idea is quite similar to the extrude up to next surface function we used previously, but in this time, instead of up to surface, we choose up to vertex, and we choose this point as the reference vertex. Now you can see that this extruded feature just nice coincide at this point. Press OK. And this feature has been created. If you feel that this dotted line as well as this plane one will block your view or anything, you can right click and click on the eye icon, which is hide. You can hide these two. If you want to see them again, just right click and click on show. Yeah, you can toggle this feature at any time at your own will. Next, we need to extrude this cylinder upwards. But do know that this 3 inches dimension is measured from the top all the way to the bottom. So in other words, we only know this full distance is 3 inches. We don't know what's the distance from this surface to here. We don't know what is this distance. So instead of creating sketch on this surface, we will create this sketch on the bottom, because we will extrude it through this solid block, and the duplicate part will be automatically removed by SolidWorks. So we'll create a sketch here, a cylindrical circle, and we know that this is actually a co-radial with these two circles are actually co-radial. So we will add a co-radial feature to it. Then we can extrude it. Extrude blind. Now we can see this direction is wrong. We will change the direction and extrude for 3 inches. You can see that this portion over here it overlaps with this existing feature, and don't need to worry. This duplicate part will automatically removed by SolidWorks. Yeah, then press OK. Next step is dig a hole through. From here, we can see there is opening below this, which is another hole. This tells us that this is actually a through hole, means it will penetrate through the entire thing. So let's see. This hole dimension is 2.25. Dimension is 2.25. And this concentric with the external circumference, so we can add a concentric relationship. Press OK. Exit the sketch. Extrude cut through all. Yep. Then I believe the last sketch, the last part, the last step will be creating this rib. So basically, we want to fill up some of the spaces over here, so we can create a rib. Of course, you can trace out this irregular shape, then like extrude it outwards. But because of this arc over here, because of this non-straight line, which is the arc over here, this extrude can be quite difficult. Because if you draw your sketch on the mid plane over here, eventually, okay, I'll draw the front view here. Eventually, this is arc, the front view. Your extruded your extruded feature will look something like this. Only the center point is touches this arc over here, and here are all empty spaces. Yeah, but if you like extruded more, then like this could occur. Yes, the empty spaces are filled, but here are some extra materials. So actually, the easiest way is to just create a rib. Yeah, the rib feature will automatically fill up whatever empty spaces it can reach. Yeah, so we can draw the rib at using the right plane on the right plane. So the only thing you need is one single straight line. It does not need to be a close sketch in this case. All we need is a single straight line. It doesn't need to, it doesn't even need to have a like a proper like a fixed lens. It doesn't even need to touch anything. Yeah. But we need to define this angle as 48. So this is 48. Although this is not fully defined, but we can just leave it. But if you really wish to fully define it, you can just assign a arbitrary dimension to it. This is not really necessary, but if you want to fully define it, you can just assign an arbitrary dimension to it. Yeah. Then after that, go to rib. You can see this arrow over here. This arrow over here. So like if your arrow is facing outwards, you can just change it by checking or unchecking this box. Then the arrow will flip direction. So basically, what rib does, there's two ways of ribbing. In this case, we will use the first one, parallel to sketch. Basically, what rib does is it will fill up whatever empty space it can reach in this direction indicated by the arrow. So you will fill all the space until you touch with this surface, this slanted surface, as well as this circular uh this uh this circular surface of the cylinder. So we want the rib width to be 1 inches. So we change from here instead of 0.1, we change it to 1 and press OK. You can see this strip is created. Over here, there's no empty spaces and there's no extra materials. Over here, it says the material is aluminum 6061 alloy. So material, we go to edit material, and we go to 6061 is a aluminum alloy, so we go to aluminum 6061 alloy, apply, and close. Then we can evaluate the mass property, 2.99 pounds. And this is the correct answer. Okay, I believe that's all for this video. Thank you.